Hey everyone, welcome to another episode of Black Guy Does Physics. Today we're going to be looking at a torque problem. If you have any physics problem that you would like this black guy to solve, please comment below. Alrighty, let's get it cracking. First things first, as usual, we look at the diagram. Why do we want to look at a diagram? So that we could upload information into our brain, concepts into our brain. Now, whenever you see a pulley problem, then all you have to say to yourself, oh, easy. This is just forces and torque. How do you spell torque again? Torque. Okay, cool. Those are the two things that should pop up in your mind. Well, there can be other things that are there, so I'll put that in blue. So if you're really good at this, then you can think of, let's say, motion, like angular motion, or just motion being angular and linear, and sometimes even energy. But those two last ones are dependent on whether or not the information that is given to you. And if, as I said before, if you're good at it and you've been looking at this for a while, then you could tell that. But for definitely, you know that there's forces and there's torques that are involved. So you just want to start there and let the problem lead you the way. I have been having this issue with my students, and I need to make sure that I mention this. When you write down the concepts that are there for the problem, you're not trying to actually solve the problem from the concepts right then and there. You're just trying to make sure that you're not lost in what you're doing, and you don't have to scramble to try and figure out how to solve the problem. All the concepts do is that they tell you where to start from. That's all they're doing. So you don't have to worry about, oh my God, what do I do with the forces and blah. Nah, man. Just take it easy and just let the problem tell you what to do. Okay? All right. So now we go to reading this problem. And let's go to red so we could underline. As we're reading, we want to underline, and then we also want to make sure that we write down what we have. So here we have a 12 kilogram box. So I would call that M1 is equals to 12 kilogram. Resting horizontally, there, frictionless. So if frictionless, I could put that there is no friction. Surface attached to a 5 kilogram weight by a thin light wire that passes over a frictionless pulley. So this is a 5 kilogram weight. So my M2 is equals to 5 kilograms. And it passes over a frictionless pulley. That simply means when it says frictionless pulley, it simply means at this axis here, there's no external torques being happening there by the pulley. So you don't have to worry about no frictional torques from the pulley itself. If there's frictional torques, the question will blatantly tell you that there are frictional torques there. Okay, the pulley has a shape of a uniform disc. Why would they be saying this? I have no idea. So I put that the shape is a uniform disc, put a asterisk right there, of a mass 2 kilograms. So the mass of the pulley, I'll put MP is equals to 2 kilograms. And a diameter of 0.500 meters. You know, for all these problems that deals with things that rotate or are circles or anything like that, you never use the diameter. It's always the radius. So you just chop that in 2. It's already in meters, so you're good to go. Hopefully my math doesn't fail me here. This is 0.25? Yeah. 0.25 meters. After the system is released, oh crap, what does released means? I think released means that the initial speed is 0. Anything that is released or dropped, the initial speed is 0. Find the tension in the wire on both sides of the pulley. Great. So tension, automatically, once it tells you that there's tension, it simply means that this is a force problem. So I'm looking for tension. Awesome. This is a force problem. So what do? We have the process in finding force problems or solving force problems. And what do we always say? Trust the process. Trust the process. The first things first that you want to do is that you want to draw your forces. And what are the forces here? Let's see. We have the weight of this thing. I definitely need to do a video on forces. I will do the video, so at a later date. Crap, this should be, let me make it straight. Got to be explicit. This one is M2, I think. M2G. This one is M1G. This is FN. Let's go make it straight. FN. There's tension here in the string going upwards. We call this T2. There's tension here in the string going this way. We call that T1. There's tension here going the string. That is also T1. And there's tension going that way downwards, which is also T2. So I have to erase this. So this is T2. And there's also T2. Now, because the pulley has a mass, the tensions in the strings are no longer equal. If you go to my previous videos where we had tensions in strings and pulleys, you'd see that it was a massless pulley. So T1 would be T2. In this particular case, T1 is not T2 at all. T1 is not T2 at all. So you do not do that. There's no frictional forces, there's no spring forces, so you don't have to worry about those things. So first things in the solving of a force problem, you draw your force diagram. What do you do next? You make your x and your y axis, then you break down any forces that are not parallel or perpendicular to your x and your y axis. For this particular problem, everything is nice, so I don't have to break anything down, so I won't waste your time. Now, as a matter of fact, let me draw that x and y axis. You should always, kids, you should always. X. See, I started to show off because I know what I'm doing, but never show off. Always respect the problem. Always trust the process and follow the steps. Awesome. So now, once you've done that, you're looking for the tension in the wire on both sides of the thingy. So, what is true? For all force problems, F net is equal to MA, but by now we should understand that F net is equal to MA is just a synonym or something for F net X is equal to MAX, and F net Y is equal to MAY. Therefore, I choose one of these blocks, any one that you want to choose, and let's say we're going to choose M2. It looks the simplest, so I go for M2. So this would be for mass 2. So for mass 2, I am going to say F net Y is equals to MAY, because the forces are only in the Y. F net Y is equals to MAY. And that simply means that you just add up all the forces that are there. Oh, crap, I forgot to say. You have to make sure that you choose directions for your forces. So the directions for your forces, and I am going to choose up to be positive, down to be negative. Up, down. In other words, towards the pulley to be positive, away from the pulley to be negative. So this way would be positive, and that way would be negative. Once you see a pulley with these forces or these tensions here, they are also going to create torque. That's what the problem is going to go towards, because once there's a force being applied at a distance from something and it causes it to turn, then you're going to have torque. So these tensions in the ropes are going to produce torque. So you want to draw those torques also. So this T1 will be causing this thing to spin that way. And this one will cause it to spin that way. Okay? So I think this one would be, which way does a clock spin? T2 will be clockwise. So that's clockwise. And T1 would be counterclockwise torque. Now I know in books they tell you that counterclockwise is positive, clockwise is negative, but let me tell you something. There's an easy way to figure out which one is positive and which one is negative. It depends on which way the things are moving. So for example, T2 will be creating a torque. T2 will be creating a torque that will cause M2 to move downwards in a negative direction. T1 will be creating a torque that will cause T2 to move upwards in a positive direction or a positive acceleration. That simply means that T1 would have a positive torque and T2 would create a negative torque. So you just see which one creates the thing to move towards the pulley and away from the pulley. Let me say that again. T1 would create a torque that would move T2 in a positive direction, because that's where the things are moving. If you notice where the acceleration is going, T2 is going down and T1 is moving towards the right. So I just choose the one that is causing the moving in the positive direction to be the positive one. I know it's kind of weird, but if you don't want to do that, then you could just do counterclockwise is positive, clockwise is negative, and go from there. But that's basically what it is. So after that, let's see. So F net Y equals to MAY. So that would give me, I'm going to make some shortcuts here. That would give me T2 minus M2G. I said shortcuts. Oh no. All right. 2 equals to M2A negative. And why is it negative? It's due to the fact that it is accelerating downwards. Negative in the negative directions. Now I could check. There's no X, so I'm good to go. Now I could check to see what I have or what I'm missing. I don't know A. Crap. I know M2. I know G. I know M2. And I don't know T2. That's what I'm looking for. So I have to find A. So if I have to find A, then I have to go to M1 and repeat the same scenario. So instead of F net X, instead of F net Y, I'm going to use F net X. F net X equals MAX. And if that's the case, then all we would have here is T1 should be equals to M1A, a positive M1A. So now you have a problem again. And as you can see, this is going to be a whole bunch of math. I apologize in advance. So now you have two equations, two unknowns, bro. Crap. Two equations, three unknowns. Is it three unknowns? Yep. You don't know T2, you don't know A, and you don't know T1. What do you do? Well, you see that you have torque. That's another concept that you could use. So you don't panic, you try and go to torque. So we go boom, and we go to torque. So let's see here for torque. We write down what is true. And what's true for torque? I think it's that the torque is equals to R perpendicular F, or F perpendicular R, or the torque net is equals to I alpha. So you always go with the torque net is equals to I alpha. So I'll go with that one. Now, if you always try to start with that one, especially if you have a pulley problem or whatnot. So now the question is, if I'm using this one, which is the torque net is equals to I alpha, what is alpha? What is I? And what is torque net? I know none of these things. I still don't panic because I'm trusting the process. I'm just trusting the process. Even if I'm getting scared, I just trust the process. Okay, so let's go. Let's start with torque net. What is torque net? Well, the torque net is the sum of the torques. So you add up all the torques. How many torques are there? 2. You have the torque caused by T1 and the torque caused by T2. The shortened version is that for any pulley problem, the torque caused by the tension is just the tension times R. Tension times R. In another video, I'll explain why, but just trust me. It's just the tension times R. So I'm using counterclockwise to be positive, so here we would have T1 times R minus T2 times R equals. Now the question is, what is I? Well, they told you that it was a disc or a cylinder, I guess. So if you want that, then you should be able to, at this point in time, you should know that you should be able to figure out what is the moment of inertia of something if you're given the mass and the radius. And for a disc, that's why they said a disc. For a disc, it's half mr squared. The next question is, what is alpha? Well, we never said that this was a motion problem. And there's a dead giveaway how you know this is not a motion problem. The reason why there is no motion problem is because you didn't get any time. If you get time, then there's a high probability it's a motion problem. There's no time, so not a motion problem, bro. So what else is alpha in? If you check all the equations that you have, there must be a relationship between A and alpha. And that relationship is A is equal to R alpha. Therefore, what is it? Let me see if my math is failing me again. Alpha is A over R. Oh, this basic math is kicking my butt. All right, so now we have this stuff. T1R minus T2R is equals to half MR squared A over R. Sweet Jesus. And that is my third equation. So now, if you want to learn about systems of equations, you go back to my previous videos, look at system of equations, and you could figure it out from there. So here, this cancels this. This cancels this. So now we have T1 minus T2 is equals to half MA. So now we have three equations with three unknowns you could solve. How do we solve three equations with three unknowns? Glad you asked. Got him. We go like this. If you watch my previous video, you'd see you have to solve for one of the unknowns. In this particular case, I know T1 is equals to M1A from equation 2. So anywhere that I see T1, I put M1A. So I could substitute. We're going to substitute T1 into equation 3. Let's see. So if that's the case, we have M1A minus T2 is equals to, oh, this is MP. MPA over 2. Great. And I could call this equation 4. Once I'm done with that, then I'm done with this equation. I don't want to scribble through it. Yes, I could scribble through it. I could put X over here. We're done with this. Let's make that better. We're done with this. We're going to put a green line. Let's go highlighter green. We're done with this one. See? We don't need it no more. We're done with this one. We don't need it no more. So now I only have two equations with two unknowns. I have T2 and A. That's the only thing that's missing. So I'm going to solve for A and then solve for T2. Or I could solve for T2, solve for A, then solve for T2, then solve for T1. I think if I solve for T2, that would make my life a little bit easier. So I am going to solve for T2 in equation 4. Yes, let's do that. I'm going to solve for T2 in equation 4. Oh man, this math sucks. But oh well, you just got to do what you got to do. Don't get scared. T2 should be equals to, hopefully my math doesn't fail me, MP, let's multiply by 2. No, it would be divided by 2 anyway. MPA over 2. So that's T2. Now what we're going to do, we're just going to substitute, man. Substitute it out. Don't know what substitute is still. Whenever you figure this out, let me know. We're going to substitute T2 into equation, what's that, 1. Sweet Jesus. All this mathematica. So I have M1A minus MPA over 2 minus M2G is equals to minus M2A. Woo, Lord. There we go. There we go. Look at you. There we go. So now we have to organize up A, get all the A's together. And how do you do that? You move all the A's to one side. This becomes, and then factorize out the A. This becomes A M1 minus MP over 2 plus M2 equals to M2G. Then you divide both sides by that long thing, M2G over M1 minus MP over 2 plus M2. Now that would be your value of A. Once you find A, you substitute it back to find T1. Once you find T1, you could find T2, and that should do it for everything in the problem. Now, ladies and gentlemen, boys and girls, do you have to go through and try and rearrange the way that I just did? No, you don't have to. You could just stuff the numbers in. If you're not fancy, don't try and be fancy, man. Just get the job done, okay? Sorry for the length of this, but hey, it's a lot of math. What can I do? All right, there we go. Another problem. Another physics problem done by the black guy. All right, cool. Well, that's it. Please comment below, like, share, tell somebody, send a smoke signal, something, and most importantly, subscribe, man. Subscribe and let that ringer ring, 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 ring. Okay? And once again, kids, don't be a moo-moo.